Okay, the recording is started, and I think I need to probably share my screen too. I don't think I did that yet. Running a little behind today here, sorry. All right, so this is the August 20th, 2019 Crossplane community meeting. And the first note I want to make today is that a few of us have a hard stop today at 9:30 Pacific. So if the conversations are still going beyond 9:30, halfway through the hour, then I'll just go ahead and transfer host over to Dan, and Dan can continue driving it for the rest of the hour. So let's go ahead and get started on just a quick look at our roadmap. We had published this merge this into master maybe a couple weeks ago. And so we are making progress on a fair amount of these right now. We've already accomplished a few of them, and the main focus right now for the next couple of weeks here will be focusing on the individual cloud provider stacks and adding, resource network connectivity type of support for each one of those, and upgrading all the controllers in those cloud provider specific stacks to use the general or generic managed resource controller, such that at the end of the 0.3 milestone, we will have each cloud provider stack in a very good shape that demonstrates the best practices and the recommended way to write controllers and the patterns for managing external resources from a Kubernetes cluster. So, what I expect, after the dust settles from implementing some of the specifics of those cloud provider stacks, we'll definitely need to update all of our user guides and the examples, etc., for how to use those and how to be successful with them if we want to take them for a test spin. So we definitely want to pay attention to the quality of that and make sure that the user experience here is up to par for people to try out the project and successfully use use Crossplane and all the various clouds that it supports. I think the project view here is pretty up to date. So let's just do a quick look at what we have in progress, and then we can move on past that. So I'll just speak through it all here so we don't have to take turns. So Marcus is going to be focusing on the implementation for all of the features that we want to add to the stack manager in the 0.3 timeframe. So the security and namespace isolation work, and also being able to add, take metadata from the packages, the stack packages, and add those as annotations to CRDs. So higher level user interfaces or tooling can just examine the CRDs to get all the configuration and metadata information they might want for each one of the CRDs that is installed from a stack. And so we already updated the core Crossplane repository to be using KubeBuilder and controller runtime v2. So the next step now is breaking out each one of the cloud providers into its own repository, so they can be independently versioned and have some isolation there of the code base. And so that Dan and I are doing that right now and we're breaking the core Crossplane logic out into a runtime repo. And then I'm working on the GCP stack repository, and we'll get in that just a little bit more on the agenda today. Excuse me. Javad is focusing on all things AWS. So Javad is going to own the AWS stack, and he's working on adding the support for networking types like VPCs and subnets and security groups and all that sort of stuff to help automate the process of getting an application up and running and securely connected to the resources that it needs to consume. Muafik is doing the same thing for GCP, And Dan will be doing a similar effort for Azure once we have rolled out all of the cloud provider specific functionality into their own repos. Daniel Suskin is working on an example stack for WordPress, so an application level stack, and what that looks like to package the logic and controller and CRDs, etc., to be able to deploy and manage an application and add that functionality to the Crossplane's core control plane. And then let's see, and then Phil is working on getting a start on some of those user guides and blog posts and marketing splash, et cetera, for the 0.3 release. So that's everything that's in progress right now. And that's, kind of as we were talking about before, that's a big focus on these three, high-level epics or items for the 0.3 milestone. So I expect a lot of rapid progress in the next 2 weeks here. And, everybody's pretty focused and heads down and going to make a lot of progress. All right. So that's the project update there on 0.3 progress. And then we can move ahead now to the community topics section. And so we have Glenn. I think Mark joined as well. Yes, I see both Glenn and Mark. So Glenn, do you want to go ahead and introduce this topic, and then we can jump into it?
Yeah, sure. Mark and I work on a project. It's actually building a FAS, but that's kind of irrelevant. It's got a collection of CRDs and controllers and so on. And Mark's done some interesting work to package bits of the project as stacks and or extensions to Crossplane. I'm relatively new to Crossplane, so I've used the wrong words. Please forgive me. But we've been wondering, in the past, we've had requirements to be able to put the images that our software uses onto a private registry so that a customer can use it in an air-gapped environment or gain control of the images for their own purposes. And so what we've been wondering about is whether there's a requirement for stacks to support image relocation so that you can ship a stack with pointing at registries out on the internet and then relocate those images to a private registry and then tell the stack to map the images appropriately. Does that ring any bells with anyone? Is that a requirement that's being looked at, or one that sounds plausible, or what?
Yeah, so thank you for bringing that up, Glenn. And so that type of functionality, it sounds like that's something that's desirable in this project, the Crossplane project as well. And it sounds like the level of thinking that we've done on it is probably a bit more or a bit less mature than the thinking that you've done. So basically what I've been thinking about so far, it was pretty naive, I would say, in the sense that how Kubernetes pods, where you can kind of specify where to pull the image from, and then provide like a image pull secrets type of functionality to provide credentials that were necessary to access that private registry. That's really the level of thinking that I had done previously on this. And so the term image relocation, where you have like it being mapped to a private registry, I'm not all that familiar with that particular the depth of this topic here. Can you talk a little bit more about what image relocation really means and what that mapping means, or what level that's performed at?
Yeah. So suppose you ship some software and it has a dozen images. There may be open source images owned by other projects. There may be ones shipped by this project, and so on. But basically, you ship some declarations that refer to these images, and then the customer wants to run those images out of their own private registry. So what they do is they run a tool that we provide, and it can be various forms, to relocate the images. And what that does is it rewrites the image references and then pushes the images to their new locations on the in the private registry. And you end up with what's called the relocation mapping, basically a map from the old locations, the old image references, to the new image references. And then you somehow have to get the software to kind of accept that. So in our case, for example, in the past, we've had Kubernetes config files with a bunch of images scattered throughout them through the YAML. And we've kind of developed tools which will essentially do a global replace of those occurrences with the relocated images. So essentially, you can then install the software, and it will use the relocated images and then pull them from the private registry. And then the kind of related aspect to this is, if you want to ship that into a truly air-gapped requirement, then the customer can't do the relocation from the internet. They can't pull from the public registries because they probably don't have access across their network. So in that case, you have this approach where you take the images and you pack them all into a tarball and then ship that with your product. And then they can relocate then from the tarball to the private registry, and again apply relocation mapping as they install the product.
I see.
I've got more write-ups and examples that I can post. I'll link those into the minutes.
Oh, sure. Yeah, that would be very useful to have, some more information to read about how that functionality works. And so it sounds like then that the relocation mapping, the information about that mapping, is that stored? Were you saying that that's normally stored at the Kubernetes, like in cluster level as a config map or some other type of data, that it's not stored on the registry server or Docker distribution server side? It's more local. That information is more local to the cluster itself.
That's the ideal, yes.
Okay, I see. And then air-gapped environments. Have you found that folks will pretty much run a container image registry or a Docker distribution type of thing just on premises there, so that over the internal network it can be accessed and not have to go out to the public internet at all because it's air gapped?
Yeah, precisely. Yeah.
Got it. Okay, that makes sense. And I think that for me, maybe other folks already understand this all very well. There's definitely folks on here that are faster than I am, but getting a better understanding of how the complexity here, or how what needs drive the necessity for this extra machinery to kind of meet the enterprise needs. So I would love to do some more understanding of that. And so that's functionality is that part of the CNAB spec, or how does it come into play there?
Yeah, it's interesting. We developed the machinery for image relocation before we got anywhere near CNAB. So we had a version where we had a CLI that could do image relocation of a distribution of our software, and then we pulled out that code into a separate repo, and we did some more experiments, and then we got involved in CNAB, and we plumbed the code into their reference implementation, which is called Duffel, and so they're using the same approach, but essentially. What I've been thinking the last couple of days is it's probably biting off CNAB is a big hurdle to jump for Crossplane, whereas actually just fixing the image relocation requirements is a lot simpler, because we've kind of got the heavy lifting is already done in a separate open source repo, and so it's just a question of having the dependency and plumbing it in and then dealing with the mapping.
I got you. Is Duffel, Glenn, is Duffel a client-side only thing, or does that have a server-side component to it too?
It's client-side only.
Got it. And where is the implementation of the image relocation that you said it's in a new repo? Was that part of the Duffel reference implementation, or is that a different repo?
No, it's a separate repo. I can put a link in the stats in the minutes.
Okay.
Go there right now. It's github.com/pivotal/image-relocation.
Okay, it's on the Pivotal org image-relocation. Got it. That sounds great. Yeah, any of those extra links and for background information and some more of that information there would be definitely really useful for me to better understand this space, and sure maybe for other folks as well. Does anybody else want to add in some comments here or have some thoughts about the image relocation?
How would this differ from say, like if Stack was, well, I'm not sure if Stack is the right answer here. If you had a pod who had an image and you just changed the image and the repository that the image was referencing, And what's the advantage of this over just dynamically changing a pod image?
It's really when you're managing a number of images from different sources. And our project was built on top of Knative, on top of Kubernetes, and has some other dependencies. So we end up with a dozen or so images, and we needed a uniform way to map them across. So having individual parameters and tweaking them wasn't really an option. And the set of images could flux, and it wasn't under our control.
Yeah, that makes more sense. So it's about doing it in like a large group, some deployment with a dozen images and changing them all right then. And the mapping isn't as straightforward. It's not as simple as just changing the repository that they're all coming from. You're renaming them, changing their tags. The mapping is a more complex mapping than just changing the repository of the images.
Yeah, the mapping's explained in that repo, in the README, but essentially we preserve tags and digests. And the crucial case is digests, because we typically ship with digested references, and then they get relocated to the same digests, different image reference.
Yeah, and it sounds like it provides some, scalability and automation to this whole need for private registries. So I think it's pretty interesting, Glenn. I definitely appreciate you bringing this to the community meeting today to kind of share this idea with us. So okay. I would love to do some more reading. I put the image relocation repo link into the minutes already. If there's other links that you have, more information, you can add those to the minutes, and then I'll accept those changes. And I would love to do some more research into this to understand it better. But I definitely like the approach here where, it's providing some scalability and to this problem that probably, a lot of enterprises are going to want to solve. So I definitely appreciate the information here.
So the other bullet there where was registry work for stacks underway was just a kind of side point, because I noticed in the stacks design doc, it talks about storing a stack package as a tar file on an OCI registry. And I started to wonder, are they using an image manifest, or is it just a layer, or what's going on? I couldn't find the code.
Right. So the assumption so far is that, that you'd be able to store a stack in any, OCI compliant registry, like a Docker distribution server. And we are hoping to, we'll have a publicly accessible registry that, can store all different sorts of stacks that, people can publish, their stacks to and share with other people. And there's nothing that's special about that right now, besides, we've been testing with Docker Hub right now. So, any regular Docker distribution OCI registry is pretty much the goal there. Of any regular container image OCI format could go in there and be the packaging standard for what would be the components that comprise the stack. The CRDs it has, the controllers that it wants to run, and some metadata about it, and all that sort of stuff.
Okay, I'm particularly interested in the representation of a stack in the registry, because we've done some similar work with Docker in the CNAB world, and they use an image manifest so that you can get you can traverse the dependency between a bundle in their case, but stack in your case, and the images it needs, so that then you can GC images that aren't used, for example.
I see what you're saying there. Yeah, we've used image manifests in other projects before to help with multiple architecture support as well. That's really useful to be able to say, hey, I just want this image, and then it automatically, the manifest tool and the manifest of the client side stuff will remap that to, oh, okay, you need ARM for the particular architecture you're running on, and that's the exposure I'd had to the manifest so far. I haven't really done much about them with dependencies fulfillment, so that's actually pretty interesting too.
I'll ask on Slack about the code code location, because I don't want to drag out this call.
Yeah, sure. Yeah, we're happy to continue talking at any time, Glenn. Definitely appreciate your contributions here.
Okay. Thank you very much.
My dog says so too. All All right, cool. So let's go ahead and move on to the next topic. We had already kind of mentioned this on the main Crossplane repo has been upgraded to use KubeBuilder v2 and controller runtime and controller tools v2. So we are now at a point where we're starting to break out the code into other repos. And so something that Dan and I had discussed was going to be important for that effort is to maintain the history. You don't want to just do a copy of the code files to another repo and lose all the Git history there. So we were doing some fancy Git operations to filter out the parts of the Crossplane repo that we want to move to new repos and maintain all the history. So we have some preview links in the meetings here of what those repos are looking like so far for the Crossplane runtime and as well as GCP stack. So like, for instance, you look at GCP stack and you can see that it's scoped to just the GCP APIs and like the GCP clients and GCP controllers. But if you look at the code, like you can see that it's got way less commits than what's in main Crossplane master so far, because it's the commits that are only relevant to GCP. And for instance, if you look at just one of the random controllers here, you still get a history of the changes that file has gone through. So when you're looking, for debugging or wanting to understand more about the GCP stack, we'll have all that history from the development iterations that it went through to get to where it is now, so you can understand why changes were made or how you have more context around how the code got to where it is. So I thought that was Dan and I thought that was really useful, and that's the method that we're using to split out the cloud providers into their own repositories. Just wanted to make a note of that. Dan, did you want to go ahead and talk about your next topic here?
Yeah, for sure. So the main thing I wanted to bring up here is, so this morning we merged the PR that converted all managed kinds to using strongly typed resource classes. So basically previously we had a generic resource class that had a parameters field, which then was basically just an arbitrary map of strings that provided configuration details for any managed service. And then there'd be a function that accompanied the managed kind that basically took those parameters and parsed out the ones that were relevant to that specific managed kind. And the issue with that is when you created a resource class, a generic one, then you weren't able to know if you had provided appropriate values or not in terms of the type of the parameters. You also didn't know what fields were required and that sort of thing. Basically, there was no schema validation. So that's one of the benefits that moving to strongly typed resource classes does. It also allows us to use the policies that we've introduced. So you can set a default for a certain abstract kind. So for like a Redis cluster, you could set it to an AWS replication group, or you could set it to GCP cloud memory store. And then you create a claim without a class reference and it'll just default to that. So we had originally thought about doing that after splitting out into the different repos, but because it was a pretty mechanical change and it would just be nice to go ahead and get it moved and not track that work separately, we went ahead and implemented it yesterday. So that is all ready to go. The one thing I really wanted to bring up here, though, is that for a very, very brief time, which I'm working on right now, the examples will not be functioning correctly in the Crossplane repo on the master branch. So I'm updating all of those from using the generic resource class to the strongly typed resource class pattern. And those should be done by the end of today or sometime tomorrow. And documentation will be updated as well. So that's the main thing I wanted to call out in case anyone was testing anything on master.
Awesome, Dan. Thank you for I was definitely very excited that you were able to execute on that very quickly yesterday to just go ahead and update all of the strongly typed classes or implement the strongly typed classes for all the cloud providers. So now that you have that, we're breaking out the cloud providers into their own repos, that work will be included there. And that's one less thing that each of the individual contributors to those repos will have to worry about. So that's a really good start. Okay, so I think that we had one pull request that I wanted to bring up here that I hadn't got a chance to look at yet, but it looks really interesting, that Javad opened yesterday, and I wanted to look at it, but I wanted to also call attention to it to get other people's feedback if they can. Javad, do you want to mention, talk a little bit about this pull request here, about the need for mapping the AMEyes to the Kubernetes EKS versions?
Yes, for sure. So previously what we have for AWS, every time that we wanted to kick off a new cluster, EKS cluster, and also after the cluster was created, we wanted to build a few worker nodes. And then for those worker nodes, we need to know what AMEyes we were going to use. Initially, we had some AMEyes which were compatible with for different regions that EKS is supported, and then specifically for that Kubernetes version that was the default version of EKS at the time. But then what happens is, like, the default version of EKS has been changed from 1.12 to 1.13, and then potentially is going to be changing later as well. And then those AMEyes are version specific. So when you're kicking off EKS clusters, the hard-coded values are not going to be compatible anymore. And then you get problems like the node cannot be joined to Kubernetes, control plane and stuff like that. So what I did, I made looking up for the AMEyes related to that version specific to cluster version. So every time that you want to kick off a worker node, it looks up to see, using an EC2 client, API client, Go client, it looks up to see was the proper AMEy image for that cluster version in that region, and then dynamically sets up and kicks up one instance of that worker node and that AMEy, rather than using the hard-coded values in the code. That's basically the summary of what the change.
Awesome. Thank you, Javad. I will try to take a look at that as well today, but anybody else who wants to dig into that is more than welcome for feedback as well. I made Dan the host now, and because I need to peel off this meeting here. And I think we're almost out of topics, though, that we had in the agenda, but I'll let Dan drive the rest of it to see if there's any more topics anybody wants to discuss. And thank you, everybody, for joining today. I appreciate it. And Dan will take it from here. Thanks, Dan.
Yeah, for sure, Jared. Thank you. Yeah, so as Jared said, here, I'll go ahead and share my screen as well, just so we have the doc up here. As Jared said, we're out of topics here. So is there anything else that anyone wanted to cover or dive into before we wrap up this call?
I just wanted to ask Glenn, that's a very interesting idea to have the flexibility of private repositories to be part of Crossplane. I was wondering, what are the specific reasons that you want to not use Docker Hub, for example, and use private registries and be able to relocate images that this feature would be useful for?
It's really enterprise customers that want to have control of the registry server. Possibly they have a separate network or maybe even an air-gapped environment.
Okay, and then so when you're saying relocation, and this is just out of curiosity, you didn't say like maybe remapping. You mentioned relocation. Is there a reason? Like, are you talking about the dynamic, like a relocation while the pod is up and running or Kubernetes up and running? Redirecting, or just like instead of like reading from Docker Hub, reading from somewhere else?
No, it's pretty static. The idea is to, before you install the software, you relocate the images. So essentially it copies the images verbatim to the private registry, preserving the digest.
Okay, so it's like before the pod comes up, it gets the image, copies it to the private registry, and then after that goes from there.
Yeah.
Okay, got it. That's a very neat idea. Yeah, I like it. Yeah, back in my previous job, we had that situation where we actually had copied all the images directly to ECS registry, but then we had to do some modification to let the worker nodes know that they have the right IAM roles to, get read registries from that private registry. But I mean, yeah, making that something that you can manifest in Kubernetes, that would be really useful. Awesome.
Yeah. Okay.
Great. So if no one else has anything, then we can go ahead and wrap up for the day. Thanks to everyone for joining, and feel free to bring up any additional topics in Slack.
Right.